Good day. We are going to present our project, GreenSort, the auto sort compact bin, under Creativity and Innovation BEE 22402 by Chen Jing-sun, Ethan Jong, Sun Wei-song, and Bunja Kwan. I'm Bunja Kwan. Why do we need GreenSort? Currently, our recycling systems are failing due to two critical issues: contamination and logistical inefficiency. When people put the wrong items in the wrong bins, it renders entire batches unprocessable. Furthermore, uncompressed waste like plastic bottles lead to frequent carbon-intensive collection trips. In Malaysia, this situation is urgent. Our 2024 recycling rate is stagnant at just 37.9% because of public confusion over packaging. While industrial robots exist, they are far too expensive for public use, creating a massive gap in our infrastructure.
My name is Qin Jin-sun. Now I will present for the cause and effect change part. We use the cause and effect change analysis to tracing the roots of why recycling cannot get a satisfied achievement nowadays. And desirable phenomena is the high contamination rate in recycling stream. This may caused by the user error. For example, the packaging label are confusing and static signal fails to capture the attention of the user, and this cause the misidentified of the user to the material of the waste. Beside the passive infrastructure, a standard bin provide no immediate feedback to correct or wrong disposal habits. And the last one is the root cause, which is the absence of a technological immediately to validate waste at the point of disposal. The next one is the engineering contradiction treats. Contradiction one is the accuracy versus speed. The conflict is high accuracy usually requires slow physical analysis. The solution is we use copying, which is a AI optical analysis. Instead of analyzing the physical object, the system use digital image. The material are easily to be classified through this way, and we also use preliminary action, which is a sensor wet the system on approach, and this can make sure the bin is always ready to use. Next one is the contradiction tool, which is the automation versus complexity. The conflict is full automation typically result in fragile and expensive device. The solution is we use segmentation for the bin. The system is segmented into two parts, which is a high-tech smart lid and the exiting of the low-tech receptacle. We also use dynamics, which is the simple gravity-based diverter flap to direct the waste. The next part is GreenSort solution strategy. The concept of GreenSort is a modular, retrofittable smart lid integrating AI computer version and a servo-driven diverter which can automatically sort waste at the point of disposal. The process of using it is when a user approaches the bin, this distance sensor will wet the system, and the user need to present the waste item in front of the camera, and the camera will identify the item in about 500 m second, and then it will display a feedback to the user, and then the cover of the bin will open and let the user to throw the waste inside it, and then the item thrown in the bin will divert to correct bin. For the design factor, a dome profile is designed for the bin to prevent the obstruction of the sensor and the camera. This avoid when the user put something on the bin and cause the camera view become obstruct, and there is also a sliding shell to cover the deposit hole until the item is identified and to prevent the beating the system.
Hi, I'm Ethan. Now I'm going to talk about the function analysis for a product. So the first one is the higher order function, where it protects the environment by saving the energy required to separate different type of waste before our product was introduced to the world. So the second one is the basic function, which is it can separate the waste automatically with the automatic sorting system inside the lid. And then the third one is the strategic omission. So how do we achieve this? Is by the key components used by our um, GreenSort bin. So the first one is the AI camera, where it identifies the type of waste that is being put inside the bin, and then it will direct it to the designated chamber, so that no energy, um, no more energy is required for the people to separate it later on. And the second one is the touch screen display. So by having this, we can receive the feedback from the users. And the last one is the diverter. So this diverter is the main components that help us to separate the different type of waste and to save the energy that required for people to do the work instead of using machines. Moving on to our next part, which is the business incentive principle. So the first point is segmentation, where we only replace a segment of the bin, which is the lid only. And by doing so, we can actually reduce our manufacturing cost, and it also allows us for a easier replacement. So our second point is universality, where we only one unit for for separating all the types of waste instead of having one unit per type of waste. And it also saves the public space since we only use one instead of more than one. And the last one is simplification, where we don't use mechanical claws to separate the different type of waste, and instead we use the gravity-based sorting so that it can lower the energy consumption and the maintenance need to maintain the lifespan of our bin.
How do we compare to the competition? As you can see in our table, GreenSort offer the active sorting of high-end units like transport, but at a low cost of roughly 500 to 800. Unlike passive screens or expensive standalone stations like Bin E, we provide a retrofittable solution that is both high accurate and educational.
So this is the design outcome of our product. So at the left side, we have a hand sketch version. This is how the product should look like, and we only replace the lid for the bins instead of the whole thing, so that it can save the manufacturing cost. And at the right side, we have an uncompleted AutoCAD version of our bin, where we also only design the top part because the bottom part doesn't need to be replaced.
Our S-curve analysis showed that we are at a rapid growth stage of AI-driven material recovery. Traditional static bins are a mature, dead-end technology, but leveraging current leaps in AI accuracy and low-cost hardware, GreenSort is perfectly timed to lead the next generation of smart waste infrastructure.
Good day to lecturer. I'm Sun Wei Suang. So I will continue for the design outcomes and the conclusion. For our design outcomes, GreenSort is developed as a modular smart lid that can be installed on existing public bins. The system includes a camera and an edge AI processor to identify the waste, a central opening for disposal, and an internal gravity-based diverter to sort the waste automatically. The cylindrical shape allows easy installation, while the dome cover protects the electronic components from the rain and dust, making it suitable for outdoor public streets. So for the part of user interaction, the GreenSort is fully touchless, which provides the hygiene in public space. The touchscreen provides the real-time feedback, such as confirming the detected waste type. And also, the gamification elements are used to encourage the correct recycling behavior. And accessibility features like audio feedback ensure the system can be used by everyone. So in the conclusion, green sorts transform the traditional passive bins into the intelligent waste sorting system. It reduces the contamination at the point of disposal, and it is cost effective and scalable, and has a strong potential to support Malaysia's recycling goals and sustainable urban development. And that's all for our presentation. Thank you for your attention.
That's all for our group presentation. Thank you.